What if the weapon that just arrived in the world's most dangerous waterway didn't fire a single bullet and still managed to destroy 30 years of Iran's military planning in a matter of seconds? And what if the people who built the plan didn't see it coming until it was already too late to do anything about it? This involves a waterway roughly 9 kilometers wide at its narrowest point. Every single day, about a fifth of the world's oil supply moves through it. Tankers, cargo ships, and military vessels all squeeze through this tight corridor between Iran and the Arabian Peninsula. For decades, Iran understood a simple yet powerful truth about this place. Control the Strait, or at least credibly threaten it, and you hold enormous leverage over the rest of the world. This leverage was never going to come from conventional military power. Iran knew it couldn't outbuild the U.S. Navy or win a direct fight against 3 American carrier strike groups and 27 warships positioned in around the Gulf. Iran's military planners were astute enough to recognize this. So instead of matching American firepower, they devised a far more clever approach. They built a trap. Not a military trap in the traditional sense, but an economic one. This strategy was known as the swarm doctrine, and to grasp the true significance of what just unfolded in the Strait of Hormuz, you must first understand how this strategy worked and why it genuinely alarmed American military planners for years. The core logic was devastatingly simple. A Shahed 136 drone, one of Iran's primary one-way attack drones, costs approximately $20,000 to build. Now, consider the cost of shooting one down. An AIM-9X Sidewinder missile costs around $400,000. A rolling airframe missile is about $900,000. A standard missile, too, is roughly $2,000. This means every time Iran launched a cheap drone and America intercepted it with an expensive missile, America spent far more money neutralizing the threat than Iran spent creating it. Scale this up. Imagine Iran launches 150 drones simultaneously. That attack would cost Iran approximately $3 million. Defending against it, depending on the interceptors used and their quantity, could cost hundreds of millions. The economic asymmetry consistently favored Iran, with ratios ranging from 20 to 1, even up to 100 to 1. For every dollar Iran spent attacking, America would spend $50, or even $100 defending. However, the financial disparity was not even the biggest problem. The more critical issue was what's known as magazine depth. Every American destroyer carries a finite number of interceptor missiles loaded into vertical launch cells before it leaves port. These cells hold a fixed count. Once these missiles are expended, the ship must return to port for resupply, a process that takes days, not hours. Iran's swarm strategy was meticulously engineered to exploit precisely this vulnerability. By launching enough drones and fast attack boats simultaneously, they could push a defending ship to the limit of its missile supply, forcing it to withdraw for resupply. This created a critical gap which could then be exploited. The goal wasn't to sink the American Navy in one dramatic battle, but to make defending the Gulf so prohibitively expensive and exhausting that Washington would eventually conclude diplomacy was cheaper than continued military commitment. For 3 decades, this strategy had genuine credibility. American naval planners honestly ran the numbers and found the implications unsettling. The exchange ratios were real, the magazine constraints were real, and the resupply vulnerability was undeniably real. Iran had discovered a truly dangerous mathematical lever, making asymmetric warfare against the world's most powerful navy a viable long-term approach. Then something new arrived on the USS Preble, an Arleigh Burke-class guided missile destroyer, as it moved into the Strait of Hormuz. Its name is HELIOS, high-energy laser with integrated optical-dazzler and surveillance. What it does to Iran's 30-year strategy is remarkably simple to describe. It doesn't merely weaken the strategy or marginally reduce its effectiveness. It causes the entire economic foundation of that strategy to collapse completely and permanently. Here's why. Every conventional weapon a destroyer carries fires a physical object. A missile leaves its launch tube, travels through space, and reaches its target after some period, even if only a few seconds. Those seconds are crucial. Iran's fast attack boats were designed to exploit them with evasive maneuvering. Their drones were equipped with electronic countermeasures activated during that flight window. The radar scattering shapes engineered into Iran's fast attack fleet were specifically designed to complicate tracking during those final moments of a missile's flight. 30 years of tactical development were all built around exploiting the gap between when a weapon is fired and when it arrives. Helios, however, fires a beam of focused energy that travels at the speed of light. At the engagement distances relevant inside the Strait of Hormuz, where targets are measured in just a few kilometers, not hundreds, the gap between firing and impact is effectively zero. Not close to zero, but absolutely zero. By the time a fast attack boat's threat warning system registers the Helios beam, the energy has already arrived. By the time the helmsman processes the alarm and attempts to turn the wheel, the engagement is already complete. The window that 3 decades of Iranian military investment was designed to exploit simply does not exist against a directed energy weapon. But this is where Helios truly devastates Iran's position. Remember the magazine problem. The idea that a sufficiently large swarm could exceed a destroyer's interceptor supply and force its retreat. Helios has no magazine. Its engagement capacity is limited by the ship's power generation, not by any fixed count of physical missiles. The 4 gas turbine generators on an Arleigh Burke-class destroyer produce between 7 and 12 megawatts of electrical power. Helios draws only a fraction of that per engagement. Its beam can repoint between targets in fractions of a second. The dwell time on each individual drone or fast attack boat target is measured in mere seconds. A swarm of 150 drones, the kind that could previously push a destroyer to the edge of its interceptor supply, now represents roughly 150 sequential 1-second engagements for the Helios beam, at a cost of about $1 in electrical power per engagement. While Iran spent $3 million on that attack, America spent only $150 defending against it. The economic asymmetry that made swarm doctrine strategically viable for 30 years has not just been reduced. It has been reversed by a factor of roughly 20,000 to 1 in America's favor. The trap Iran spent decades constructing has just become the most expensive mistake in its military history. Now, consider the implications for the geography of the Strait itself. The waterway is only 38.9 kilometers wide at its narrowest point. Iran deliberately positioned its fast attack boat bases close to the Strait. Short transit times from coastal cave networks to the shipping lanes were an operational advantage, allowing for quick launches, rapid engagements, and swift retreats before conventional responses could be organized. This proximity was a key feature of the swarm strategy. Now, that proximity is a liability. The moment an Iranian fast attack boat leaves its concealed berth and enters international waters, it enters the Helios engagement envelope. There is no staging area outside the beam's reach where the fleet can assemble, coordinate approach vectors, and optimize a simultaneous multi-axis attack. The Strait is 38.9 kilometers wide, and the engagement envelope covers it from boundary to boundary. Iran's home ground has just become the laser's coverage zone. Let's also address something often overlooked in competitor analysis: the detection problem that Helios simultaneously solves. Iran invested heavily in making its fast attack fleet difficult to track by radar. Hull shapes were engineered to scatter radar returns rather than produce a clean reflection, and surfaces were designed to make fire control radar struggle to achieve a solid tracking solution. This was expensive, technically sophisticated work, and it was operationally effective at complicating the picture for interceptor missiles that rely on radar guidance. Helios, however, uses radar for initial detection at range, then transitions to electro-optical and thermal imaging for the actual engagement. Herein lies the problem for Iran's fleet designers. A fiberglass boat moving at 92.6 kilometers per hour through warm Gulf water, the powerful engine generates a significant thermal signature. This signature is completely unrelated to the hull's radar cross-section. You can shape a hull to scatter radar energy all you like, but that design work does nothing to mitigate the heat pouring off the engine. Radar cross-section reduction and thermal signature reduction are entirely different engineering challenges, requiring entirely different solutions. Iran optimized for one, while Helios targets through the other. 30 years of sophisticated naval design investment aimed at defeating radar tracking have been rendered irrelevant by a system that never needed the radar return in the first place. Now, let's discuss something called lamprey, because the Helios deployment becomes even more significant when understood as part of a paired system. The Strait of Hormuz presents not just a surface challenge. Iran's military threat operates in 2 domains simultaneously, above and below the waterline. Above the waterline, we see fast attack boats, drones, and cruise missiles. Below the waterline, Iran deploys its Ghadir class of submarines, small diesel-electric vessels specifically designed for the shallow water environment of the Persian Gulf. where navigable channels typically range from 30 to 60 meters deep. With small acoustic signatures, diesel-electric propulsion, and the cover provided by constant commercial traffic, these submarines represent a persistent torpedo threat against surface ships enforcing any blockade. Lamprey is Lockheed Martin's extra-large unmanned undersea vehicle, an autonomous underwater system specifically designed for shallow water operations in environments like the Persian Gulf. Its acoustic signature is engineered to blend into the ambient noise of commercial shipping traffic. It can track and follow contacts, including the Ghadir submarines that Iran has positioned as its underwater threat layer. Helios addresses everything above the waterline. Lamprey addresses everything below. Together, operating from the same hull, they represent the first integrated above and below waterline defensive solutions, specifically designed for the exact threat environment, Iran, constructed in the Strait. Iran's swarm doctrine was built on the premise that simultaneous multi-domain threats would exceed any single defensive architecture's ability to manage. The Helios and Lamprey combination is a direct answer to that premise across both domains at once. The strategy that Iran's smartest military planners spent decades designing to attack above and below simultaneously, overwhelming the response, has just encountered the integrated response it was designed to prevent from ever existing. Now, let's be honest about what Helios cannot do, because serious analysis requires acknowledging real limitations rather than presenting any single system as a perfect solution. Atmospheric conditions matter. In heavy rain, dense sea spray, smoke, or artificially generated aerosols with the right particle distribution, the beam's power density at operational range is reduced. The Persian Gulf's humidity and temperature create conditions where this is a real operational variable, not a defeating limitation, but a weather-dependent factor that planners must account for. There is also a thermal management constraint. A sustained, extremely high-tempo engagement against a massive swarm over an extended period could potentially approach the system's cooling threshold before every contact is addressed. This constraint is real. However, here's the critical context for both limitations. Iran's drone inventory has been significantly degraded by over 75 days of conflict and blockade restrictions on component supply chains. Generating a swarm large enough and sustained enough to exploit Helios's duty cycle constraint would require capabilities Iran currently does not possess. Furthermore, the diplomatic timeline does not afford Iran the months of engineering work needed to develop and calibrate countermeasures against a system whose actual operational parameters are now being established in live deployment. Limitations are real, but they are not currently exploitable by the organization facing this weapon. Let's step back and consider what this deployment communicates. Helios operating in the Strait right now is not routine. It is a deliberate strategic message delivered through hardware rather than words, aimed at multiple audiences simultaneously. To Tehran, it signals that the economic advantage your swarm doctrine provided has been addressed in the exact theater where you plan to use it. To the URG's hardline commanders, who have publicly declared renewed war likely, it warns that the second round they are preparing for will encounter a defensive capability that their 30-year investment was not designed to address. To Beijing, Chinese military planners have been observing the Hormuz conflict as a live validation environment for their own anti-access and area denial doctrine. The People's Liberation Army has built its naval strategy around the same economic logic Iran used. Saturate the defense, exhaust the interceptors, find the window. The DF-21D and DF-26 carrier killer missiles, the YJ-12 and YJ-18 anti-ship cruise missiles, and the naval drone swarm concepts PLA Aviation has been developing, all share the same foundational assumption about exchange ratio economics. Helios's operational confirmation in a live, contested waterway is a direct message that those economics have been inverted in real conditions on the same class of destroyers that would operate in any Taiwan scenario. To the Gulf states, it confirms that the system designed to defeat the drone and missile attack profile that has hit your civilian infrastructure throughout this conflict is now operational, and to the diplomatic process itself, every hour Iran delays the concessions needed to end this conflict is another hour, in which American defensive capabilities in the theater are being upgraded in ways that make any second round more decisive, not less certain. Iran's institutional response to the Helios confirmation is itself revealing. Within hours of the deployment becoming known in Iranian military intelligence channels, The ERG's information apparatus produced public statements calling the system overrated, untested in real combat, and susceptible to countermeasures already being developed. Read those three responses carefully, for each one tells you something the ERG didn't intend to reveal. Calling a threat overrated is what an organization does when that threat is significant enough to require managing the psychological impact on its own forces. If HELIOS were genuinely irrelevant, there would be no rapid public response to its deployment. The speed and specificity of the dismissal are evidence of exactly how seriously it is being assessed in the rooms that produce the dismissal. Untested in real combat is technically accurate in a narrow sense. HELIOS had not previously been confirmed operational in a live contested waterway, but it ignores the extensive testing specifically designed to replicate the Hormuz environment's temperature, humidity, atmospheric conditions, and threat geometry. You do not deploy a directed energy weapon to the world's most contested waterway as its first operational test. The deployment decision reflects confidence in a comprehensive testing record. Susceptible to countermeasures we're developing is the most revealing statement of all. It is simultaneously an admission that those countermeasures don't yet exist in operational form against this specific system, and a signal that the development cycle is only now beginning. There's an enormous gap between a countermeasure designed against a theoretical system, estimated from laboratory observations, and a countermeasure calibrated against a confirmed operational system, whose actual beam characteristics and engagement geometry are now established through live deployment data. Iran is at the beginning of that calibration process, and the diplomatic timeline does not provide the engineering time required to close the gap. Here is what Iran's strategic position looks like on June 2, 2026. The conventional naval force is gone. The missile infrastructure coordinates are in American targeting databases. The coastal fast attack network has been substantially degraded. The proxy network across the region is dissolving as funding dries up and ammunition runs out. The economic lifeline is sitting in 73 tankers going nowhere. Food inflation is at triple digits. Hard currency reserves are being rationed. The population is experiencing material conditions unlike anything in the Islamic Republic's history. And now, the one remaining economic advantage that 30 years of asymmetric military investment created, the exchange ratio mathematics of swarm attack against interceptor-based defense, has been reversed by a deployed operational system in the specific waterway where the ERG planned to use it. The ERG-C is not simply out of conventional military options. It is out of asymmetric options at the economic level that made asymmetric warfare against American power viable in the first place. The Mosquito fleet strategy was always about the math. The math changed. And it changed at the worst possible moment for an organization simultaneously managing economic collapse, internal fragmentation, and a ceasefire whose continuation is described by the American president as something he's not sure he wants. The Gulf state leaders who personally guaranteed an imminent deal, including no nuclear weapons, knew HELIOS was coming. Their intelligence picture of American operational posture is detailed and current. When they staked personal credibility on that guarantee, they did so, knowing that the American defensive architecture in the theater was about to eliminate the last economic rationale for continued Iranian military resistance. That guarantee wasn't optimism, it was a calculation made in full knowledge of the pressure accumulating on Iran from every direction simultaneously. The hardline commanders declaring war likely on state television are performing the most consequential institutional calculation of their careers right now. Do they accept concessions that feel like surrender and preserve the organization? Or do they push toward a second round against a defensive architecture that has systematically addressed every military advantage they built over 3 decades? $1. That is what it costs to defeat the swarm that Iran built 30 years of military doctrine around. $1 per engagement. And the Strait of Hormuz, that narrow, contested corridor that was supposed to be Iran's ultimate leverage point, will never look the same. The organization that built its entire strategic identity around asymmetric economics is now sitting in mountain bunkers, doing the math on what $1 per engagement means for every option it has left. The answer to that math will determine whether this ceasefire holds, or whether everything that comes next is answered by systems moving at the speed of light. The math changed. The question now is whether the people holding the cards understand what changed, and whether they accept what the numbers are telling them before the window closes entirely.